All right, so now what we want to do is we want to work on some examples. Again, the focus of this is area problems on the coordinate plane. So again, I'm sorry my copy didn't come out real well. I hope yours does. But we're just going to do problems that are on the coordinate plane, area problems. Okay, so number one here says find the area of a triangle. The very first thing I'm going to do, or try to do at least, is write down the formula for area of a triangle. Again, I'm comfortable going 1/2 times the base times height. If you would like to use base times height divided by 2, that's fine as well. We don't have that information given here. But notice, here's my right angle, right? So I look to that, and I know that the sides that make up that right angle are my base and my height, okay? Because they're vertical, they're horizontal, they're meeting at 90 degrees. You have to count, okay? So 1, 2, 3, 4. So even though you don't have that information given, we can get it by counting. Same thing on the bottom here. 1, 2, 3, 4, 5, 6, 7. If you can count that information, then we just plug things into our formula. Area equals 1/2 times our base. I'll say it's 7. It doesn't matter if you put the 4 first though. Times 4. Type it into a calculator. We can multiply in any order. So 7 times 4 is 28. Half of 28 is 14. Okay. Put 1/2 into a calculator, times 7 times 4. That's fine. And again, these are done in square units. Now I've been writing the SQ period units. If you wrote this as 14 units squared, that's okay too. My focus is not on the label, it's on the fact that you know how to put the numbers into the formula. Okay. Area of a triangle. Don't overthink it. The tricky part with this is they don't say, hey, the side is 4 and the side 7. You have to get that information from the coordinate plane. Another example. Find the area of this figure. Well, this is a crazy looking figure. It looks like some kind of capsule or something. I don't have a formula for some kind of capsule. So what you do is you break it into pieces you know. Okay? So if I look right here, and I'm not going to draw this picture very well, but that looks to me like it's a half circle. Over here, looks to me like that's a half circle. So I can find the area of those semicircles, as we did from the last lesson. And then it looks in here, like we have a rectangle. And I know how to find the area of a rectangle. Okay? So now I'm going to find the area of 2 semicircles, but if you said, hey, Mrs. Messing, that's just the area of 1 circle, that's fine. Okay? So the area of a semicircle, remember, we take the area of a circle. Area of a circle is pi times the radius squared, and then we divide it by 2. Okay? So the area, I need the radius here, right? The radius is the distance from the middle of the outside, so that's 1. So I'm going to go pi times 1 squared divided by 2. All right, so just use a calculator for this, and as soon as we multiply by pi, remember, it's going to be an approximation. That's okay. All right, so 1 squared. So if I go 1 to the second power, that's 1 times 1. That's just 1, right? And then if I multiply it by pi, so I'm going to go times my pi key. Well, 1 times 3.1415926. It's going to say that number, right? So I've done 1 squared times pi. Now I'm going to divide it by 2. And you'll see that I get about 1.57, we're going to say. Okay. All right, so I know the area of this is about 1.57. Well, this is going to be the same thing. It has the same radius, right? So I know the area of this one is 1.57. Now I need to find the area of this rectangle. And the area of a rectangle is length times width, or base times height. There's no right angle symbol there, but that's what we know that is. Okay, because it's meeting straight up and down. So this is 1, 2, 3. So this bottom here is 3 units, and this is 1, 2. So that's just going to be 3 times 2, and 3 times 2. 3 times 2 is 6. So the area of this thing here is 6. So I basically just have to go 1.57 plus 6 plus 1.57. And we get 9.14. So our area is approximately 9.14. I don't have any units, so I'll just again say square units. So this is what's going to happen. As you're going to see in another couple examples here, we're going to have to break this up into pieces. Find the area of the things you know, and then just put it all together. This next one, pay close attention to, because I believe there's something like this on your homework. Okay, this one tells us that the area is 12 square units. Well, our quadrilateral, parallelogram, well, this is a parallelogram. The area of a parallelogram is base times height, or length times width. I don't know why it switches up like that, okay? And it's telling us that the area is 12. So 12 equals, now, this line right here, notice how it's going straight down. They should put a right angle symbol there, but they didn't. It's telling us that that's x units. My base, they don't give us anything, but we can count. From 1 to 2, there's 1, 2. This has a length of 2 on the bottom. So we can say our base is 2 and our height is 6. Or I'm sorry, our height is x. This looks way more confusing than what it is. If we know the area is 12 and we know the base is 2, we can figure out what our height is, okay, by using this formula. Our area is 12, so I put 12 in for area. Our base, I counted to get 2, and our height they're saying is x. Well, 2 times what number equals 12? And if you didn't know, remember we can undo multiplying with dividing. Whatever we do to one side, we do to the other, and we get x equals 6. So what does that mean? As I try not to be quite so sloppy. Okay, it means that our height, our x here, is 6. And it's just units. Okay, don't overthink it. Take the information you're given off the coordinate plane and plug it into the formula, but always write down the formula. One more. All right, this is a trapezoid. It's not a parallelogram, so I can't use the area equals base times height. But I can break this up into 2 figures. Okay, I have this rectangle. Oops, not what I want to do again. Click on the right button. Okay. I have this like rectangle right here. And then I have a triangle. Do we know how to find the area of a rectangle and the area of a triangle? Yes. So the area of a rectangle, base times height, length times width, doesn't matter. They don't give us numbers, so we count it. 1, 2, 3, 4. This is 4 units down here. And going this way is 1, 2, 3, 4. This is 4 units. So 4 times 4 equals 16. Now for our triangle right here, remember, area of a triangle is 1/2 the base times the height for our equal sign. So again, count it. How long is this bottom here? 1, 2. Now, go for the right angle. Don't try to count this one. Okay, on a coordinate plane, we can only go count the one straight up and down and sideways. So this is 1, 2, 3, 4. Well, again, we said that right here. It was 4, right? So we're going to go 1/2 times 2 times 4. 2 times 4 is 8. Half of 8 is 4. So the area of the whole figure is 16 plus 4, which is 20. So we would say the area is 20 square units. All right, so a couple takeaways from this. Write down your formula. On the coordinate plane, sometimes you're going to have to break apart figures and figure out the area of each one and then put it back together. And make sure that you know that you can count. Take a look at the scale, make sure they're going by ones. And on the coordinate plane, you can count the missing side lengths and then use that with the formula to find the areas.